The E2 reaction is one of our two primary elimination reactions. In this reaction, we take some sort of alkyl group that has a good leaving group, we add a strong base to it, and as a result, we convert it into an alkene. And it's termed E2 because just like with the SN2 reaction, the rate determining step in this reaction is bimolecular. So how does this reaction work? So in a single step, we add a base to our starting material, and that base removes a hydrogen on the carbon next to the leaving group. We shift the protons down, make the new alkene, and kick out our bromide here, or whatever our leaving group might be. Two major things that we want to talk about as they relate to the E2 reaction. One, what is it that differentiates E2 versus SN2? Both of these are bimolecular reactions. Both of them involve to something like an alkyl halide or some sort of alkyl group with a good leaving group. But the key here is what is the reagent that we add. And if our reagent here is a strong base or even a good base, then E2 will predominate over SN2. But if the substance that we add is not a good base and it's just a good nucleophile, in that case SN2 will predominate. The second piece is in a compound like this one, we have two possible protons we could remove. We could remove this one I've labeled HA or this one HB. And the product I've shown, I've removed HA. Had I removed proton HB, we'd get the product I've drawn below in gray. And so for most elimination reactions, we find that most elimination reactions follow what's known as Seychev's rule. And Seychev's rule says that the more substituted alkene is generally favored. And that's because the more substituted the alkene is, the more stable it is, and easier it is to form in this reaction. Now, so the major product from this reaction would be the first one that we drew, where we can see that our alkene is substituted twice, whereas the lower product, the one in gray, only has a single substituent on the alkene. Later on, in another video, we will talk about a reaction known as the Hofmann elimination. And the Hofmann elimination, based on using very specific leaving groups and very specific bases, is able to prefer the less substituted alkene. But in general, most E2 reactions with most leaving groups, most bases, we get the more substituted alkene.